So I'll start. So hi, I am Deepon. Sadly, the other two co-authors, Tanmay and Professor Raj, could not be here today. So I'll be presenting CycleDistill, a new way of bootstrapping machine translation with the help of LLMs using cyclical distillation. Okay, so even before going through what a method is, we should discover what the problem is, right? So here I have shown you an example of Llama 3.1 8B. This is a sentence in Niwari. It's a dialect of Nepali, and we told it to translate it to English. So as you can see, it didn't even follow the main instruction of translating it to an English. So the actual translation is something like this, which is very much orthogonal to what output it has given, right? So the main question or the challenge that we want to solve is simple, like how can we make translation tools and using small models. In our case, it's less than 10 billion parameters without using any massive data sets or any kind of massive data sets or massive language models as well. So we introduce CycleDistill. So the main idea that we do here is bootstrapping, or in Indian context, we call it jugaad. So we will use something that we already have, which is we'll have some amount of data in those languages. We'll try to use a method to get the model to learn with least amount of data. So this is like the uh, rough flowchart of sorts to to understand what we did. So initially we started with a pre-trained model, and we told it to generate some synthetic data, and we did sequence level distillation first with the model itself and one with the smaller model. And once the same model, the self distillation has been done, we again use that model as the teacher now, and we kept doing this iteratively. This is the main idea that we did for the cycle distill. Later we understood that this is not understanding how yeah, wait, let me discuss this, sorry. So the one question that many people had raised is, why did we even do iterative? Like, we could have stopped after one step, right? So at start, whatever the base model, let's name it M0, it's not really good. It's, to some extent, it can generate some text. So after distillation, after one step of distillation, we saw that the student M1 is much better than M0. So the synthetic data generated by that will also be better than whatever the first data that was generated. So even this paper, iterative back translation, had actually shown that any kind of like this iterative process is very intuitive, and it actually shows promise in the long run. So that was our motivation for why iteration. Next, we did something called iterative soft distillation. Instead of just doing normal sequence distillation, we wanted to learn, we wanted to match the teacher's probabilities with the student probability distribution as well. So we just did we defined a loss function with the Kale divergence, which is as shown as the mathematical equation. And we thought this will actually, let's say for complex languages, which will have a harder representation space, harder for the model to learn, this will probably capture those nuances and understand it better. So that was our understanding. Here's a small diagram to show what we did. So at each token, it was doing that, and it was trying to minimize the loss, which was based on the basic normal distillation concept of KD. And so we did few experiments. So the experiments, we wanted it to be as diverse as possible. So the time the experiments were done, Gemma 2 was released, and Llama, I think 3.2 was released. So again, we did Gemma 9B with itself and Gemma 2B as a student. We did Llama 8B with itself and 3B as a student. And we focused on three languages: Hindi, Bengali, Malayalam. Malayalam is not very the lowest resource language, but within these three, this was the lower resource language. And we did all the metrics are in CHRF. The system prompt that we have used is as follows. It's a small system prompt which just tells, try to preserve the cultural nuances, try to preserve um, all the nuances that come with the language and try your best. And the reason we chose CHRF over Blue is actually this paper from 2019 ACL, which showed that for low resource languages, CHRF is a better metric than Blue is. So the setup that we did was that we took 20,000 samples from BPCC seed. These are all monolingual samples. We took 4 short duolingual parallel corpus and we prompted it to make the data. We did it for 3 iterations only. The reason was very simple because after 3 iterations, the improvement was very tiny. So we also had a compute crunch. So we did not feel it's worthwhile to waste the compute more than 3 iterations. And we also evaluated on the full samples from in22 gen, that is 1024. So the first cycle of distillation for both cases only, we saw 20 to 30 point increase in CHRF. So you can see this diagram was for Hindi. And if you see the right diagram, you will see for softmax preserved distillation or the second process, Malayalam, the lower resource language, which was also culturally and also linguistically more nuanced than Hindi, our soft distillation method was actually increasing CHRF from the first iteration being less than 20 to almost 50. So illegible to legible. Later we also saw that one shot setting was best for languages. Like for 4 shot, there was a huge collapse seen. For example, you can see this is one example. For the paper we have evaluated the whole suite. You'll see on 4 shot we are seeing some problems. That's why we didn't we felt like one shot was giving the best results in our case. And we did some short ablation studies as well. So does a better teacher indicate that there will be a better student in our case? So in 0 shot, yes, as good the teacher is, we are seeing that that good the student will be. So that's what we found out. In 1 shot, we saw that the difference was not that much. So like it's well distributed among the whole plot. So and 4 shot again because of that huge the 4 shot prompting, we saw because of complex languages not being able to capture the 4 shot examples, there was collapse. So not a correct way. Finally, we also did one extremely low level, the Nepali example that was shown before, and Manipuri on the Meiteis script. Nepali we actually improved. So for example, you can see Llama 8B base is 12 CHRF. Finally, after 3 rounds, it's 54. So it's illegible to legible again. But in Nepali, we saw since the Meiteis script is not much there in any models, pre-trained models, so it did not give good results. So one takeaway we found out is that the model should know at least a bit of that language to even emulate the synthetic data to run the process as well. And we also showed that versus Llama versus Gemma, we saw Gemma had the better like capability to hold the language. And so again, the model of languages, models we are evaluating matter as well, is one conclusion we gained from this. We also came about propagation of error through iterations. So a short story, we messed up one iteration once, like the second iteration, we had fine-tuned, we had distilled on some wrong data, which led to cascade of errors basically. And the errors propagated so much that in the last iteration, we were seeing drops of to 30 to 40 CHRF. And this is an actual output from the error propagated model. So it does not make sense at all. So the Hindi word says I am at WAT 2025, but the answer is just some nonsense Hindi words. So conclusion, what did we learn? So first we learned that we can build high quality translation models with just 4 short examples. And yeah, we saw huge performance gain. So like a model from being illegible in one language becomes legible in one language with just 4 duolingual samples and some amount of monolingual samples, which are much easier to get rather than duolingual samples. And the improvements will flatten out after 2-3 cycles. The error propagation risk is real, so please always be careful while doing this whole architecture. And performance will drop for complex languages with very big prompts. So we did not explore some questions in this project, and as the spirit of research we will like to tell some open research problems which we didn't explore but people would like to explore. So does this translate over non-indicant low resource languages, because we just evaluated on low resource languages. And what if we run it for more iterations, right? So we have iterated till 3 and we saw it flattened out. Does after some iterations it starts growing again? What if the plateau is something we are imagining in the first place? And third, can we mitigate the problem that the model needs to know the language at first, maybe find some technique so that even Manipuri can be solved in this aspect? So thank you. This is the paper website and link. You can scan it, and I think we'll be open for questions.
It's a very interesting work. I do work in 17 languages, so I know the translation quality we get, particularly for Malayalam, which is agglutinatively rich, and the words are so concatenated. How did you come up with the number 2000, 20,000?
That was
Or can we go little lesser also?
no, we haven't explored that as an ablation. That was more of like a empirical vibe, to be honest. Like 20,000 data is something. Anyway, the reason that we did was that I was fine tuning some models on 20,000 data. So I was like, can we do it with 20,000? That is there is no like solid proof based thing, but that can be a cool ablation study to do a plot against like 5,000, 10,000, 20,000, 40,000.
Thank you. Very nice work.
Hello. Yeah, hi. So I noticed you're using knowledge distillation in the sense. So how much smaller is your student model?
So for Gemma, it was 9B versus 2B, and for Llama, it was 8B versus 3B.
Okay. And I saw you're using token-wise scale distillation, right?
Yes.
So I'm not sure this is just a suggestion from my side as well. So have you tried pruning the vocabulary to restrict to only those languages and do knowledge distillation on smaller models?
No, that's a good suggestion. Okay, I'll look into it.
Okay.
We haven't done that.
Okay, because that'll so most of these models have very huge vocabulary space. So then most of the parameters would be on embedding space rather than actual model learning. So it might be helpful to do
Yeah,
small.
that might improve logical.
Thank you.
Hi, thank you for the presentation. I probably missed the point. Do you use any parallel corpus?
Can't hear you. Can be a little.
Do you use any parallel corpus during the cell?
No, so the only parallel corpus is the force shot. So basically, I'll show you the example. Wait a second. So if you see in this, the initial model is generating synthetic data, right? So it's just that one force shot. This generation is on done force shot. That is the only parallel corpus that is used in the whole process. Rest all are monolingual.
Oh, which means you use only for example and like do
Yes, yes.
I see.
So there is no parallel corpus in the whole thing except those four shot examples. The rest of the things we just did what we got BPCC seed. So BPCC seed is again a machine translation thing. So basically it has, let's say, English, Hindi, right? So we strip the Hindi out. We just keep the English one basically. So with that monolingual data, we have four shot prompting to generate this synthetic data set. So we are emulating that parallel corpus using monolingual corpus basically.
Okay, thank you.
Thank you.
I think you are using the same models for the initial and the teacher model, right?
Yeah, so there are two cases. One is with the same model.
You are using the same models for the initial and the teacher model, right?
Yeah, so there are two cases. One is with the same model, means self-distillation kind of. One is with a student. So we have done two studies basically parallelly.
Could you go to the slides where the models you used?
It's here. Yeah. So it is Gemma 9B to 9B, and another case is Gemma 9B to 2B. So we have done both.
Yeah. So what if you use Gemma for teacher model and the Llama for the self-distilled model?
As in, like, okay, so means inter.
Yeah.
Right. So yeah, we didn't try that out,
Yeah.
but yeah.
I don't know if I don't know. It happens that this model is very strong at this language, and the other maybe.
So no, one thing that we did, which is not reported in the paper, but I'm just discussing here. So the initial proof of concept for this was done across only. So the bigger model was Gemma 9B and the smaller model was Llama 3B back then. And yeah, so the proof of concept in that also we saw improvement. That is why we pursued this. So that's not reported in the paper, but yeah.
Okay, I'll check it. The questions?
Yeah, actually, to Nakazawa-san's point,
Okay,
I
yeah,
just wanted
please.
to make one clarification. You can do distillation from Gemma to Llama and Llama to Gemma only if you rely on data, sequence level distillation using only distilled data. But if you want to also use the KL divergence between the softmaxes of the student and the teacher, then you cannot do that because the vocabularies will be different. So if you are simply generating synthetic data or distillation data with a larger model, then it doesn't matter what the student model is. But if you want to do the KL divergence between the softmaxes, then you cannot do it. So that's why we didn't focus on that aspect too much.
Yeah, I see. Okay. Thank you for the clarification.
Thank you.
Okay, so